Alright, for problem number 1, we're told that we have 4 different types of bread, 6 different types of meat, and 8 different types of cheese, and we want to know how many different sandwiches we can make. Well, for this type of problem where we have 3 different categories, we're just going to multiply them all together. So 4 times 6 times 8 turns out to be 192. And that's the different number of sandwiches that we can make. Question number 2 says, how many different ways can we order 8 songs on a CD? Well, you got 8 for the first song, 7 for the second song, 6, and so on until you get all the way down to 1. So really we just have 8 factorial, so we go into our math PRB number 4, and 8 factorial means that we can order our songs in 40,320 different ways. In problem number 3, they have us a license plate that we need 2 letters and 4 digits. And we need 2 letters followed up by 4 digits. So there are 26 letters, and we're not told that we're not allowed to repeat the letters, so I'm going to do 26 times 26. And then we got 4 digits, so we got 10 times 10 times 10 times 10 for our 4 digits. And when I multiply those all together, it turns out that there are 6760, so 6,760,000 different ways that we can have a license plate. For problem number 4, we're asked how many different ways can we choose 5 lotto numbers out of 35. Now, because the lotto does not care about the order in which you pick them, or else no one would ever win the lotto, order doesn't matter. So when I pick 35, I'm going to divide by 30 factorial, but I'm also going to divide by 5 factorial. 5 is the number picked, 30 is the number not picked, and this is called a combination because order doesn't matter. So when I do this, I'm going to do 35 factorial divided by 30 factorial divided by 5 factorial and get my answer. And so there are 324,632 different ways that you can win this lottery. In problem number 5, there are 18 people, and we have president, vice president, secretary, and treasurer, which means that, oh, I didn't include treasurer, so I'm going to erase that. So we have 18 people, and each position is different, so it's going to be 18 factorial divided by 15 factorial. This is the number not chosen. And so when I do this, I'm going to just divide by the one number, not divide by 2 numbers, and so there are 4,896 different ways that we can pick the president, vice president, and treasurer. Problem number 6 asks, how many different ways can we arrange flowers in a circle? Now, because we don't have a starting point, the first one doesn't matter. So in our circular permutation, we're going to do 5 factorial, which means that we will arrange them in 120 different ways. In problem number 7, it asks how many people can you arrange around the table if there are 8 people and 1 comfy chair. Now, since there's 1 comfortable chair, we're going to do 8 factorial because everyone wants to sit in that one particular chair, so it makes a difference. In that case, we're going to get 40,320 different ways. And that is the review for permutations.